Power system planning. In the last videos, we have discussed the introduction of power planning, national and regional planning. Today I am going to discuss structure of power system. Structure of power system. An electrical power system can be considered to consist of generation, transmission, sub-transmission system and distribution parts. The component of an electrical power system include generator, designed to convert mechanical energy into electricity, transformers, transmission lines which are used to transfer power from one location to another, and auxiliary equipment. This is the generation, transmission and distribution. The electrical power is generated at a plant with a typically voltage of 22 kV or 11 kV voltage. Here in this example, we have used the 11 kV voltage. These voltages are usually specified line to line. Further, this voltage is boosted by using this transformer 220 kV or 400 kV voltage. Further, this voltage is stepped down up to 33 kV or 11 kV. This at the receiving station. This is called the primary transmission. Most of the major industrial customers have their own transformer to step down the voltage 33 kV supply to their desired levels. The motivation for these voltage changes is to minimize transmission line cost for a given power level. Distribution systems are designed to operate for much power level and are supplied with medium level voltage. Further, this voltage is stepped down 6.6 kV or 400 volt or 230 volt. The distribution system contains loads that are commercial type or residential type. Usually the commercial customer are supplied power at voltage level of 11 kV, whereas the domestic customer get power supply at 400 to 440 volt. Since domestic customer get single phase supply, they usually receive 230 volt, while a domestic customer with a low power consumption gets single phase supply. Both industrial and commercial get three phase power supplies, not only because their consumption is high, but also many of them use three-phase motors. To reduce the losses and make the transmission possible, we have to convert the generation voltage to much higher value and to reconvert them to lower ones at the receiving end, at the load center. These are the main key point of the structure of power system. An essential component of power system is the three-phase AC generator known as the AC synchronous generator or alternator. The source of the mechanical power, commonly known as the prime mover, may be hydraulic turbines, steam turbines whose energy comes from the burning of coal, gas and nuclear fuel, gas turbine or occasionally internal combustion engine burning oil. The transformer transfers power with very high efficiency from one level of voltage to another level. The power transferred to the secondary is almost the same as the primary except for the losses in the transformer. An overhead transmission network transfers electrical power from generating unit to the distribution system, which ultimately supplies the load. High voltage transmission lines are terminated in substation, which are called the high voltage substation, receiving substation or primary substations. The distribution system connects the distribution substation to the consumer service entrance equipment. The primary distribution line supplies the load in well-defined geographical area. The industrial load are composite load and induction motor from a high proportion of these load. These composite load are function of voltage and frequency and from a major part of the system load. These main points we have discussed in the figure which are shown here. In the next class, we will discuss the tools of the power system planning. Thank you.